Bismillah. Assalamualaikum. My name is Muhammad Syahrul Aiman. So, for the introduction from this project, theoretically, it can be understood that electric power quality is the travel of voltage, frequency, and waveform of the power supply system in accordance with the specification. Power quality also generic term for disturbance-free electricity supply. Deviations occurring in sinusoidal voltage waves resulting in this faulty device are referred to as disturbance of quality. So we have four phenomena. Number one is voltage surge, voltage swell, transient, and lastly harmonic.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farhana binti Hussein. My metric number is DE180102. Methodology. First, we go to block diagram. First, understand the project instruction. Find out the power quality problems, include their solution. Choose a suitable power quality problem and its mitigation. Run a complete simulation using MATLAB. Write a technical report and record a video for presentation. Flowchart. We start and open the MATLAB simulating software. Next is design the chosen circuit diagram. Next is apply three conditions of distribution system and record all the results and then end.
Hello, my name is Nur Hadipa binti Mortar and my metric number is DE180104 and I would like to explain about the result for the voltage sag occurs in distribution system. Okay, for the source we use 11 kilovolt source feeder and connected to the transformer which is step down transformer. It will reduce the magnitude of voltage to 400 volt and this is the load. Okay, whenever there is no power quality problem, so this is the waveform for transformer and load voltage. So both of them are in sinusoidal shape, but the injection voltage is 0. Okay, for the current, the transformer and load current are in sinusoidal shape, but not the injection current. Next, for the second condition, whenever the voltage sag is occur at the three phase, the all three phase at the 0.04 second to 0.08 second. So the shape for voltage will happen like this. From the 0.04 second until 0.08 second, both the transformer and load voltage are has a bit drop which is almost 0.5 pu. Same goes to here. Okay, for the current. Okay, so same, it is same shape. It has a bit distortion here, and also the value of current drop. So the injection current has the same shape as before, but the magnitude is different. Okay, for last condition, which is whenever we apply the VR, which is one of the mitigation technologies to overcome the voltage sags. So the DVR is is meaning for dynamic voltage restorer. So the whenever the as we can see here the voltage transformer has a bit drop, but whenever we apply the DVR, so it will inject the voltage so that the load voltage will increase up to 1 pu. So it will be the same amplitude from initial to the end. So for the current, it has the same amplitude, but is has a bit distortion here for the both transformer current and also the load current. But for the injection current, the amplitude before the implementation of TVR and after is the amplitude of current become increased.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatina Jiha binti Ahmad Kambali and my metric number is DE180122. I will explain about the analysis and discussion from this project. The topic that our group had choose is mitigating the voltage sag by using dynamic voltage restorer. The simulation that we had choose is MATLAB. From this project, we know the voltage sag is voltage were reduced for a few seconds and the voltage is came back to normal, being able to come back to normal over a period of time. The causes of voltage sags is faults, transformers energizing, and starting motor. Our group had choose face-to-face, which is line-to-line fault, to simulate in the MATLAB as the power quality problem. So the figure shows the result that we get from the simulation in the MATLAB. This figure shows the voltage, so we can see that when the fault is applied, the voltage is reduced for a few seconds and came back to normal. This meets with the voltage set meaning. For the current, it same goes to the current where the current is reduced for a few seconds and came back to normal. Okay, next, the dynamic voltage restorer. We had choose the dynamic voltage restorer to mitigate the voltage sags in the power system. The function of dynamic voltage restorer is to mitigate power quality problem, which is voltage sag, voltage swell, and other more power quality problem. The dynamic voltage restorer is functioned by inject the voltage required by magnitude and frequency to make sure the load voltage came back to normal. Next is load voltage is being able to restart again after the fault. Next, the function dynamic voltage restorer can be functioned even though the voltage at the source is unbalanced and distorted. And lastly, the DVR is connected in series to line via interfacing transformer to regulate load voltage. We can see in the figure when DVR is connected to the power system, we can see at the load voltage where the voltage had been reduced early came back to normal where there is voltage injection produced by the DVR. Same goes to load current. The load current waveform, we can see the current is came back to normal, where there is injection current from the DVR. Okay, from this project, we get to know some impact of DVR towards society and environment. The first is reliability, where DVRs help to improve in load industries. It also helps in reduce frequent losses and improve the reliability in basis load point, which is average rate failure, annual outage interruption, and expected interruption cost. From using the DVR in the power system, the benefits that we can get is we can reduce the cost. Next, high capacity and low losses if we use the dynamic voltage restorer. And lastly, the dynamic voltage restorer is the most effective solution as its function can bring the voltage interruption came back to normal.
Conclusion. Nowadays, at least voltage sags are reasonably understood, as high-frequency phenomena such as switching transient are less well understood, more difficult to model, and their statistics are likely to show more variation among different customers. There still cause problem with the equipment. High frequency disturbance may well become the next major issue of power quality. Single phase rectification, such as computer, consumer electronic, process control, adjustable speed drive, and variable speed drive, are the particularly important. The magnitude and duration of the voltage cycle will affect a single phase corrector. Consumer ride for longer than a certain duration when the voltage falls below a certain voltage. With additional capacitance on the internal DC bus, the device voltage tolerance can be easily improved. It is more elegant but also hard to use a voltage regulator that can operate down to lower voltage.